Trigonometry review, part 2. So we have question 5. We are trying to find the missing angle. And that's up next to the cave. Now, if you're looking at your triangle, you can see on the inside we have no angle measures. But we do have an angle measure out here. With this measure, and this is a straight line, we know from here all the way around is 180 degrees. So we can figure out this one by doing 180 minus 58. And we get 122. So our inside angle is 122. Which means we now have a relationship with this other opposite side, which means we can use law of sines, and then we're going to use this relationship to equal it. So let's set up this one over here. I'm going to do my x first. So we have an x right here on the numerator. It's an angle, so we write sine in front. Over its related side, 2.6, is equal to this guy. So what's up top is an angle. So we have to put our angle up top, 122. Whenever you have an angle, we put a sine in front of it, and it's 3.72 on the outside. Now we're going to solve for x, so we multiply both sides by 2.6. So this crosses off, and we're left with sine x is equal to, I'm going to do my 2.6 first. Does not really matter, but I do like to move it, just because it looks better to me. Alright, and then the final thing is I'm going to take an inverse sine of both sides so that these cross off. And so we're left with our purple x is equal to all of that. So we have inverse sine 2.6 times sine of 122 over 3.72 parentheses. Okay. So I'll go and type it just like that in the calculator. Let's see, can you see both here? I'm going to turn my lamp off. There you go. I think that's bright enough for you. So inverse sine 2.6 parentheses for the sine of 122. I got to close off this parentheses for the sine. Divide by 3.72. And then I have two parentheses here. One for the parenthesis that I inserted right here. And then one more for the initial sine parenthesis. Equals 36.35. And I'm going to have us round to the nearest degree, which I did not write here. So it'll be 36 degrees. So x equals 36 degrees. Okay, next question. Convert to radians. Okay, so this is we're going to multiply each of these by pi over 180 degrees. So if we do that, pi over 180, these cross off, and we're left with just pi. This one's pi over 182. Okay, so we can divide both these numbers by 5 at the very least. I'm going to try actually 15. And 135 over 15 does go whole, so it's 9. So 9 pi over 180 divided by 15 is 12. So if you look at this, we can divide by 3 one last time, which means we can divide both these numbers by 45, if you didn't know that. Divide by 3 is 3 pi, and this is 4. So 3 pi over 4. 570 times pi over 180. Okay, well, we can cross the zeros off at the very, very least. 57 pi over 18, and both these can be divided by 3. So 19, and 19 is a prime number. So those are our 3 answers right there. Okay, convert to degrees is very similar, however, the exact inverse of these, 180 over pi. This way our pi will cancel off. So 180 over pi. So like the first one up here, our pi will cancel off, and we're left with 180 degrees. Okay, so this one is pi over 2. I'm going to rewrite this. Times 180 over pi. Pi's cross off. 180 over 2 is 90 degrees. And then 9 pi over 4 times 180 over pi. The pi's cancel out. If we do 180 divide by 4, what do we get? We get 45. So we can just do 180 over 4. So this turns into 1. We're dividing that by 4. And this by 4 is 45. So now we just have 9 times 45. So 45 times 9 is 405. Okay. Find the trigonometric values of the following. So we have two different angles here that I want you to do. So the first one up here is cosine of 5 pi over 4. Oh, you can't see that. There you go. So we draw a little unit circle. 5 pi over 4. Well, first thing we want to do is convert this to degrees so we know how far around our circle it is. So we're going to multiply by 180 over pi. Those cross off. We did 180 over 4 earlier. That was 45 and 1. So we have 45 times 5 is our degree. 45 times 5 is 225. Okay, so now we have that. Now we got to figure out how far around our circle we're going to go. So from here, around our circle, we're going to go. So from here to here is 90 degrees. So we start here at 0, then we go to 90, then 180. So we're past this because we're trying to go to 225. And then down here is 270, which means that we're in this area somewhere. Change the colors out. So our angle comes out that way. Now from 180 to 225, how far is that? Well, that is 45 degrees. So we have a 45 degree angle right here. And 90 degree angle right there. I just drew a triangle in. So we are trying to find cosine, which is the adjacent value, that's this guy right here, over this. And we know this is 1. So all we have to do, this is a circle, not an O. Maybe I should make it actually an X. Make that an X. There you go. To do that, we're going to use this triangle. Okay. So I would write these triangles down. I'm going to write that up first. So you should write this on your review somewhere, and this on your review somewhere. Okay. Now, so on this sheet, if I put this right over the top, okay. See my 45 degree angle is right here inside. I didn't mark it, but that's my 45 degree angle. So this is 45 right there. Okay, so that my triangle goes like this. If I know that this side right here is equal to 1, which it is, it's a unit circle. So I'm going to set x square root 2 equal to 1. Okay, and solve for x. So I divide both sides by square root 2. And I get x is equal to 1 over square root 2. And I need to radicalize this, so I'd multiply by square root 2 over square root 2. So the bottom becomes just it's 2 times 2 is 4, and square root of 4 is 2. So then we get x is equal to square root 2 over 2, like so. And if you look back at, we're trying to find this unknown, which back here is simply equal to x. So our cosine value is this right here. There's just one small thing we have to notice. Because we're going from our origin to the left, that's a negative direction. So this number needs to be negative. Okay, it's really important. If that negative sign is not there, you cannot get full credit. At most, you get half credit for that question. Sine 30. So let's do one more triangle. If you need a negative sign, by the way. I'm not going to guarantee that the question I give you will have a negative sign. Depends if it goes left or right, or if it goes up. Up will be positive, down will be negative. So we're doing sine 30. So let's draw. So 30 is between here and here. And it's on the lower side. We get a triangle coming down. This is our 30. So here is our 30-degree triangle that you should have written down. Well, this side is equal to 1. So we're going to see 1 is equal to 2x. Thus, x is equal to 1/2. And going back to our 30, 60, 90 triangle. We're looking for sine, which sine is opposite over adjacent. So opposite is our y value, and adjacent is 1. Sorry, not adjacent, hypotenuse. Opposite over hypotenuse, and our hypotenuse is 1. So in this triangle, once we do find for x, once again, we're lucky, fortunate that this value is x. If we were asking for cosine, we would just do 1/2 times square root 3, which would be square root 3 over 2. But this time it's just x equals 1/2, or I should be putting y in this situation. These are y values 1/2, and it's up, it's positive. So our two answers are right here. Negative square root 2 over 2 is the value of cosine 5 pi over 4. And then sine 30 is equal to 1/2. You can actually check this in your calculator too. If you put sine of 30 degrees in there, you should get 1/2 out. And there you go. You can do that same thing in the calculator for radians. However, you have to change your calculator to radians. I haven't really showed you how to do that yet, so I wouldn't do that. Okay, question 9. Angle theta is located in quadrant 3. So let's draw. Let black pen go. So unit circle, coordinate system. We have quadrant 3, which is 1, 2, 3. So here's our angle. And we always draw a triangle to the x-axis. It's a reference angle, that's what it's called. And it says sine of theta is negative 12 over 13. Well, this is our angle. And sine is, remember, opposite over hypotenuse. So hypotenuse is here. And our opposite angle from our origin angle is going to be negative 12. Well, it wants to know what cosine. I have cosine written twice. That's a mistake. Cosine of theta. Well, cosine of theta is adjacent, which is our x value, and that'll be negative, don't forget that, over our hypotenuse. So we already know our answer is going to be over 13. We just have to figure out what our x value is, and it's going to be negative because it's going to the left. Our sine is negative because it's going down. Okay, so to do that, we have to do Pythagorean Theorem. A squared plus b squared equals c squared. So we have a squared, which is our unknown, plus b squared is 12, or negative 12, but negative 12 squared will turn positive. So I'm just going to put it positive right now. And then 13 squared. Our a and b can be any numbers. Remember, your c must always be your hypotenuse. So from here, I'm going to square my numbers. So I get a squared plus 144 equals 169. I'm going to move over my 144, so that cancels out. A squared is equal to, that's a 44, so it's 25. And then if I square root both sides, A is equal to 5. So my answer would be negative 5 over 13.